Okay, so today we're going to be talking about rational exponents. A rational number is just any number that can be represented as a fraction. And so therefore, pretty much every single exponent that we deal with is technically a rational exponent. Today, however, we're going to focus on exponents that are in fraction form. So we have the definition of rational exponents. We have here b raised to the p divided by q. So what that tells us is that we are going to, let me get my thinner line, we are going to have b is going to be our radicand. That means it's going inside our radical. Q, which is the denominator of our exponent, becomes the root and goes right there in the little v. Then we're going to stick the whole thing in parentheses, and p becomes our exponent. And that's all there is to this. So we're going to rewrite each of these expressions using radical notation. That means taking it from the exponent here to the radical like we have up here. So we have our base of 4. So the first thing we're going to do is draw a radical. And inside, we're going to put the 4. 4 becomes our radicand. Radicand is the number inside the radical. Our root is going to be 3. So 3 goes over the little v. And in parentheses, and then we're going to raise it to the second power. So that's all there is to this. We're just reorganizing data. So next one, we have 16 as our base. So 16 becomes our radicand. Our root is 2, and our exponent is 5. And finally, number 3, we have our base here is going to be 5xy squared. So all of that is the radicand, 5xy squared. We're going to have the fourth root, and we are going to raise it to the third power. Now, the parentheses I have here are not technically necessary. However, it's a good habit to put them on there because you'll need them when we go backwards. Anytime we learn to do something in math, we also learn how to undo it. So now we're going to rewrite these expressions using rational exponents. So looking at number 4, we have the square root of 8. And what we know here is that when we have a radical that has no root, the default root is 2. Default is 2. So anytime you have an empty radical, that's the same thing as putting a 2 in the v. So every time you see that, imagine there's a 2. Put a 2 there. So we have our radicand is 8, so therefore 8 becomes our base, and our exponent is going to be a fraction with 2 as the denominator. And then the numerator, if there isn't one, we don't have an exponent here, so the automatic default is 1. So this becomes 8 to the 1/2. If you wanted to test to make sure you did that correctly, you would go to your calculator and open it up to a calculator app. And you take 8, use your exponent button, raise it to the 1/2 power, and hit enter. And then to make sure it's the same, you're going to hit Control and then your square button, which will give us the square root. We're going to put 8 as the radicand and hit enter. If these two numbers match, that means we have our exponents in the right place and we're good to go. So let's go ahead and go back. So now we have the cubed root of x. So again, our radicand becomes our base. We make a fraction exponent. The root is the denominator. The root is right here. And the numerator is 1 when there's not an exponent. Now, number 6 is particularly special. We have the fourth root of 3x all raised to the third power. Because 3x is our radicand, we must put that in parentheses so that our exponent will apply to the entire term and not just the x. Our root is 4, so that's going to be our denominator, and our exponent is 3. That becomes our numerator. If we don't put the 3x into parentheses, let's say we write 3x to the 3/4, Now that 3/4 only applies to the x, and therefore it is not the same expression. And that's actually all you need to know about rational exponents. It's very simple. We're just going to rewrite them and use that information in later lessons.